Arrays are a fundamental data structure in ZCubes. Here we see a set of 10 numbers. The notation to generate a straight one-dimensional series of numbers is 1 dot dot 10. So dot dot is a notation to generate a series from a starting number to an ending number. You can give an interval by putting another 2 dots along with it. So you can generate as long a series of numbers as you want, and you essentially get, in this case, a single dimensional array. To create a two-dimensional array, it's very simple. This is a two-dimensional 4x4 array, an identity matrix. Any number between 2 bars gives you an identity matrix of that size. Now you can construct other sizes of arrays. For example, you could construct a 6x2x3x4 array with this notation. You put 2 bars inside and you indicate what dimensions you want to make a multidimensional array. If you provide an array as the last parameter of this notation, be able to fill those arrays with the values that are given as the last parameter. And this could be as simple as 1 to 10 in spaces of 2. Fill these 6x2x3x4 array with those values, and you can see that it has been already filled. So it's very simple and easy to create very complicated array structures. Now, there are many very interesting notations in ZCubes. So the @ operator is a technique of giving an array on one side and a function on the other side, and you apply the function to the array. So in this case, you will get an answer which says the number for the numbers 1 to 10, these are the values of the sign function. Now, you could also have given an array of functions on the right side, and it will give you a result showing both these numbers. But what I wanted to show you here was, if you had assigned this to a variable a, what happens is that once the result is assigned to a, the data structure that is used by the system is quite interesting. In this case, the input that was used to create this array, sign, is stored in the input member of the variable a. So a.input would give you the inputs that we used to create the output that you saw from 1 dot dot 10 at sign. Now a.header will have the header that you're supposed to display when you're displaying it on a screen, for example. So when we display a, it combines the input, the header of the input, and the header of the output to create this two-dimensional representation of the result of 1 dot dot 10 at sign. Now, the interesting thing is, if you had checked for the size of a, it'll still say 10 by 1, because the output is the only thing that is really stored in a. The header and the input are stored separately. Now, this is very interesting. It just means that you're able to take the input that caused your particular output. For example, as you could see in this case, if you had 2 arrays, 1 to 5 and then 3 to 5, and you did chi-distribution function, in this situation you want to know what, for example, 0.09, 0.909, 795, 989, 568, 9501, what was the combination of inputs that gave that output. So here it says the number and the degree of freedom for 1 and 4, the output is this. This is very interesting, a way to remember and use that information later when you want to really use a variable, not just printing out, but for some other purpose. For example, graphing and stuff, you could use that information. So this structure is used all over internally, and it helps you to track and understand what and how these functions can be applied and understood.